Okay, this chapter is all about factoring or breaking apart a polynomial. For example, and we are on, if you look at this page, it's day one, but I'm not going to teach you this year because of COVID. We're going to go down to the second page already, which is called the distributive property backwards. And the whole chapter is all about factoring. When you hear the word factor, it means to break apart the polynomial into parentheses. Simplify means to put it back together without parentheses. So we're learning how to do things backwards, like the distributive property. The greatest common factor goes on the outside, and the rest of it goes on the inside. And that's how the distributive property works. So here we go. So this is in factored form. Factored form, you use parentheses. Simplifying it by doing the distributive property is putting it all back together again without the parentheses. So this is simplify. What we are learning in this chapter is we're learning how to go from this way back to this way for the whole chapter. And they're going to give it to you in this form, and you have to put it back into factored form. And factored form uses either 1 or 2 or even 3 or 4 parentheses depending on how difficult the problem is. So today you're going to learn how to do the distributive property backwards. They're going to give it to you in this form. You're going to take out what they have in common with each other. That's the GCF. And if you take a 3 out, you're going to have an x left in that one. If you take a 3, it goes into 6, 2. And the reason why you're dividing is because when you do the distributive property, you multiply here and here. So when you go backwards, you divide. So that's the whole point of this. So this is the polynomial. The first thing you need to do is you need to find the greatest common factor, what they have in common with each other. Do you notice that they both have at least a 5 in common with each other? What that means is 5 can go into both 5 and 10, and they also have at least one x in common. Everybody see that they have at least one x in common. The greatest common factor goes on the outside, and the rest of it goes on the inside. So I'm going to put the 5x on the outside, and then what I'm going to do is take that and divide it into that, and the only thing that's left, 5 goes into 5 one time, so you don't have any 5s left. You have one x on the outside, you're going to have one x left on the inside, plus 5 goes into 10 2 times because you're dividing, remember, but you don't have an x right there because you already took out the x. And now I'm going to go a full circle, and I'm going to do the distributive property. 5x times x is 5x squared. 5x times 2 is 10x. Do you see that this and the one up above are exactly the same answer? So I know I did my problem right. Okay, the next one. You have another polynomial. And what we're going to do is we're going to put parenthesis out here. And we're trying to figure out what number would go into all 3 of these numbers. So I'm just going to throw some numbers out like 2 and 3 and 5 and 7 and maybe 6. Does 2 go into all 3 of those numbers? Does 2 go into 4? Yes. Does 2 go into 6? Yes. And does 2 go into 14? So far 2 goes into all 3 of those. Does 3 go into 4? No. Does 5 go into 4? No. Does 7 go into 4? Does 6 go into 4? Let's try the number 4. Does 4 go into 4? Yes. But does 4 go into 6 evenly? No. So my greatest number that goes into all 3 of these is a 2. And then you take the smallest amount of the variables. They all share at least one x with each other. So that's called the greatest common factor. 2 goes into 4 2 times. You're left with 4 x's for the first term, minus 2 goes into 6 3 times. You have one x out there, that means you have 2 left on the inside. 2 goes into 14 7 times. You took out the x, so you don't have one left. And I know I did it right, because now in order to check it, I divided to figure out what was going inside. Now I'm gonna multiply back out. That's gonna end up being 4x to the fifth for the first term, minus 6x to the third for the next term, plus 14x for my third term. And that gives me the same answer that's in my red. No, you do not have to do this part. I only want this part, but you might want to check it mentally. Okay, let's do a couple more, and that's about it. The greatest number that goes both into 8 and 12 is a 4. 4 goes into 8, and 4 goes into 12. You can only take what they have in common for the variables. So one of them has 2 A's and the other one has 1 A. You can only take 1 A because that's all they have in common with each other. You can only take 1 B because that's all they have in common with each other. And they have 2 C's in common with each other. And that's called the greatest common factor. 4 goes into 8 2 times. You took 1 A out. Notice you still have an A left. You took all the B's out and you took all the C's out. So the only thing you have left is a 2A on the inside, minus 4 goes into 12 3 times. You took out the A. You still have 1 B left in there. And you can, that's all I want. So this is the problem, and this is the answer. There's not a lot of showing work in this chapter. You either know what you're doing or you don't know what you're doing on the problems. But it doesn't hurt to multiply. 4 times 2 makes 8. A to the second, B, C to the second. And then take all that and multiply it by that, which is a negative 12. A, B squared, C squared. And that equals that. A couple more and we're pretty much done. A couple more and we're pretty much done. Let's make this, instead of 36, let's just make this a 6. This is a common mistake. So let's make that a 6. What does an 18, a 12, and a 6 all have in common with each other? They have a 6. They do not have a variable in common with each other. 6 goes into 18 3 times with an x. 6 goes into 12 2 times with a y. And this is a common mistake. 6 goes into 6 1 time, not 0 times. Final answer. If I took the 6 and I multiplied it out, I should be back, and I am. And the last problem, why don't you see if you can do this one on your own, and then there is a second part that we're also going to do today. So why don't you shut it off, and why don't you try to do it by yourself, and then put it back on, and I'll be back showing you what to do. Okay, they have at least a 5 in common. They have at least, nope, they don't have an x in common. This one doesn't have an x. But they have at least 1 y in common. So the GCF is 5y. 5 goes into 35 7 times. There's still an x squared there. Minus 5 goes into 5 once. You're going to put a 1 there. Plus 5x and y. And you know you did it right because I just checked it mentally doing the distributive property. Okay, that was the distributive property backwards. That was the first way of factoring. Now comes the second way. So I want you to come out of there. And I want you to go to day 2. And this is the second way. And these are on the same worksheet. So that's why you're doing both of these today. So there's only really 2 pages. I'm not going to do the third page. I'm not going to teach that because of COVID. This is the only 2 pages we're going to talk about. Another way to factor. It's called a difference and sum of 2 squares. See the title of it? Okay, so I'm going to show you, this is what you did back in Algebra 1. You did the FOIL method. Y times y is y squared. Then you did the outside term, which is a negative 2y. Then you did the inside term, which is 2 positive 2y. And then you did the last 2 terms, which is a negative 4. It's called the FOIL method. First, outside, inside, last. What happens is these cancel out because they're opposites of each other. And you're left with y squared minus 4. Okay, let's do one more. Let's do one more FOIL. 2a times 2a is 4a to the second. 2a times a negative 3 is a negative 6a. 3 times 2a is a positive 6a. And a positive 3 times a negative 3 is a negative 9. These two are opposites of each other. They cancel out. So you're left with 4a squared minus 9. So what's the difference between Algebra 1 and now Algebra 2? Again, you are going to be given this, and you have to put it back into factored form, which is parentheses. You are going to be given this, and you have to put it back into factored form, which is that. So we're going to learn it backwards. So here's the way we learn it backwards. You are going to be given this. And if you are going to be given this, you're going to put two sets of parentheses down. There is no greatest common factor like you were just taught a couple of minutes ago. There's two A's, so you're going to put one A here, and you're going to put one A here, and you have two B's, you're going to put one B here, and one B here. And notice what your signs are in order to do this. Minus or plus or minus. So basically it's called the difference of two squares. Difference meaning subtract, and squares meaning that these numbers on either side of the minus sign are perfect squares and you can factor it. Okay, the next one, a squared plus b squared. Notice that there's a minus and a plus. You can't factor. Things that can't factor is going to end up becoming prime. So watch out for the ones that have a plus sign because you can't factor it. This is what some kids like to do. They think it's an A and an A and a B and a B, and they think they both should be plus. But when you check it by doing the FOIL method, you get A squared, AB, another AB plus B squared. These don't cancel out. This makes A squared plus 2AB plus B squared is not the same as that, and that's why it cannot be factored. Okay, so this shouldn't take long. It looks like I've got a bunch of them to do. Looks like we've got 1, 2, 3, 5 of them to do. Okay. This is not like the last one. There is no greatest common factor. So you're going to notice that there's a minus sign right there. This is perfect and this is perfect. So you can have two sets of parentheses. An x goes here and an x goes here. A perfect 49 is 7 and 7. And the signs are minus or plus or minus. The signs, it does not matter. You can do minus or plus. Okay, the next one. It's a minus sign, and again, on either side, you should notice that they're perfect squares. So you just need two sets of parentheses. I make my z's like this. So you're going to put a z and a z, you're going to put a 5 and a 5, and a minus and a plus. So you have to recognize that this is called the difference of two squares. Okay, let's do another one. Some people think it should be 50 and 50. But when you multiply those together, it does not make 100. It cannot be 50 and 50. You're trying to come up with a perfect number that's exactly the same, and it's 10 and 10 minus y and plus y, and you are done. Okay, the next one, we have two more problems and we're done with the notes. Notice that this is perfect and this is perfect. 81 is 9m squared and 9m squared. 16 is not 8, it's 4 and 4, and it's a plus and it's a minus. And the last problem of the day, notice that there's a plus sign right there. Right there and then, you just have to write prime down. You cannot factor it, and I showed you why it cannot be factored. The sum of a square cannot be factored. And maybe you want to, you can go back to the first page. This is prime, the sum of two perfect squares. Okay, that's all the notes. And you're going to do worksheet number 1. for today.